Hello and welcome to Mrs. Law's class. In this video, I'm going to show you how to solve polynomial inequalities in one variable. So let's first recall quadratic inequalities. So a quadratic inequality in one variable may be in one of the following four forms. So these all look the same on the left side, but we have less than or equal to, greater or equal to. So those are inequalities. And also the a, the b, and the c values are all real numbers, but a can't be 0, or otherwise it wouldn't be a quadratic anymore. Now, you can solve quadratic inequalities graphically or algebraically. And the solution set to a quadratic inequality in one variable can have 0 values. So for example, if I have a parabola and the parabola faces up, but my left side, which we'll call y, I want it to be less than or equal to 0. Well, there aren't any parts of the graph less than or equal to 0, so there is no solution. Now, it could also have one value. So let's say we have a parabola again that faces up, but this time it just touches the x-axis at one point. So again, I want y is less than or equal to 0, so there would only be one value that satisfies this inequality. Now the other solution set is to have infinite number of values. So let's say that we have a parabola, and this time it opens down like this, but doesn't touch the x-axis. But again, if I ask you to find y values that are less than or equal to 0, now all of these y values in the quadratic, in the parabola, are less than or equal to 0. So all of these solutions, there's an infinite number because the graph keeps going down, we would have an infinite number of values. Even if we have the graph pointing down, but it does cross the x-axis, we would still have an infinite number of values. All right, so let's take a look at what the steps are to solve an inequality. So the first step is to solve the related equation equal to 0 to find the roots. All right, so I'm actually going to do this below with an example. So we have x squared plus 2x minus 8. So we're going to solve this as if it were just an equation. So we need to factor. Now the only difference is I'm going to keep the inequality symbol. And here now I have x equals -4 and 2. So I have the roots. So step 2 says plot the roots on a number line. Now I find it helpful to do this so that we can visualize where the numbers are. So we have -4 and 2. Okay. All right, so if the inequality is less than or greater, we're going to use an open circle, since these values are not solutions to the inequality. Now, if the inequality is less than or equal to, or greater or equal to, like the example that we have here, we're going to use a closed circle, since these values are solutions to the inequality and they are inclusive. Okay, so now you will see that the roots, -4 and 2, it will most likely divide the number line into 3 intervals. Not always, but most of the time. So now you can use test points to determine the intervals that satisfy the inequality, meaning that it makes the inequality true. So for example, f of x, if I plug in a number that is smaller than -4, let's say -5, if I plug it into here, I will have negative, and this value, this factor, will also be negative. So negative times negative is positive. In the middle interval, let's pick 0. So if I pick 0, this first factor will be positive, the second factor will be negative. So this will be negative. In the third interval, if we pick 3, this will be positive, and the second factor will also be positive. So this is positive. Now this should make sense because if we take a look at this quadratic a little bit more carefully, we can see that the coefficient, the leading coefficient, where the x squared is, it is positive. So we actually know that this parabola opens up. So if we actually graph the parabola, we would see that the ends of the parabola are actually positive, but the part in the middle is actually negative. So that's actually also is probably a quicker way to think about it if you know what the graph looks like. All right, so what we are looking for is, because it says greater or equal to 0, we want to know where the intervals are positive. Where does the graph have y values that are positive? So this occurs where y is, oh sorry, not y, this because we're solving for x. This occurs where x is less than or equal to -4, and also where x is greater or equal to 2. So the solutions would be these two intervals here. All right, let's take a look at another example. So here we have -2x squared plus 7x minus 3. There's actually a couple ways you can do this, so I'm going to show you both. Okay, so the first one is, let's say that we factored out the negative. Okay, and then what we're going to do is we're going to factor. So this factors to be 2x minus 1, x minus 3. I don't like factoring with a negative leading coefficient, so I usually like to factor it out or get rid of it. All right, so here we have our interval, and we have half as one of our solutions, or roots, and 3 is our other root. Now I can see that this is a negative coefficient, so therefore I have my parabola is going to open down. Okay, so therefore this interval is negative, positive, negative. You can also use test points like I did in the previous example. All right, so from here we want the solutions, as you can see from the symbol here, where the graph is greater than 0. Where is the y values, my left side, greater than 0? And you can see that occurs in the middle. So the interval would be from half to 3. Now this time I didn't put the equal part in the inequality because my question doesn't have the equal part, so my answer will not have it either. All right, now an alternative way to do this is, I don't like the negative, so I'm going to divide the whole question by the negative. So I would get 2x squared minus 7x plus 3, but because I'm going to divide the left side and the right side by -1, or I can think of it also as multiplying by -1, my inequality sign switches. So instead of greater than, it's now going to be less than 0. Okay, so then I'm going to factor like I did before. Okay, so this time when I draw my number line, I still have my half and 3, but this time I have a positive leading coefficient, so I'm going to draw a parabola that opens up, which means that this is positive, negative, positive. It's different from the first one, but notice that in my question, my inequality is now less than. So according to my graph, the part of the parabola that is less than 0 is again the middle portion, so between half and 3. So again, either way, you will get a solution where x is between half and 3. All right, so let's extend this to polynomial inequalities. So the method that we just used for solving quadratic inequalities can also be applied to polynomial inequalities. So the only difference is that there are going to be more roots and hence more intervals to check, unless you kind of already know what the graph looks like, which hopefully you do. So in this question, I've already have the polynomial factor. So we can see that the x's are -3, 2.5. So we can plot these on the number line, -3, and then half, and then 2. Now, one way that you can think of it is you can actually plug in all the numbers. So a number less than -3, probably 0, and then 1, and then 3. However, we do know this is a cubic equation. It has 3 x's, and the leading coefficient is positive. So we know that this graph goes from the bottom left, from third quadrant, and it goes up to the first quadrant. So the graph would look something like this. Now we don't know how far below or how far above it goes, but that doesn't matter. The important part is that less than -3 is negative, then it's positive, then it's negative, and then it's positive. And the solutions that we want is where is the graph less than or equal to 0. So where is it negative? So according to our graph, this would be x is less than or equal to -3, and also between half and 2. And notice I used the inequality with the equal sign because the question has the equal part. And this would be my solution. All right, let's do one more question. So in this polynomial, we'll have to move the 15 to the left side first. So this will be greater than 0. So we're going to list our possible zeros. So according to the constant, our possible zeros will be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So I can see that 1 probably doesn't work because I'll have a lot of negative numbers here. So we try -1, and we get 1 minus 18 plus 32 minus 15. The negatives are -33 plus 33, so that's going to be 0. So that's awesome. That works. So we're going to plug in -1 into our synthetic division. So this will be 1. Notice that we're missing x cubed, so don't forget to put the 0. -18, -32, and -15. All right, so we're going to do synthetic division. So we can do this kind of quickly. Oh, sorry, that's -17, 15, and 0. So then we're going to do this again. We have the same constant number, so we can use this same possible zeros. And let's just try -1 again. Okay, so we now have x cubed minus x squared minus 17x minus 15 greater, or actually we'll just put it equal to 0 now. All right, so then we get -1 minus 1 plus 17 minus 15, and that equals 0. All right, so -1 does work again. Okay, so we're going to do our synthetic division again. Okay, and then we get 0. Great. All right, so what we have is factors of x plus 1, another factor of x plus 1, and then x squared minus 2x minus 15 greater than 0. So we're going to factor the trinomial. X minus 5, x plus 3. So we have -1, -1, 5, and -3. All right, so I'll just squeeze this in here. So when I draw my graph, I'll have -3, -1, and positive 5. Now you'll notice that there's a double root of -1, and our leading coefficient is positive, which means that our graph opens up because it's also a power of 4 because it's even. Okay, so this means that it's going to come down, go back to -1, and because it's a double root, it's going to hit -1, come back down, and then go through 5, and then continue up. Okay, so notice if I know what the graph looks like, I actually don't have to draw or test any values. So we can see this is going to be positive, negative, and negative in the middle, and then positive. So according to our inequality, remember that we want values where it is greater. Okay, so this would be x is less than -3 and x is greater than 5. So that is how you solve a polynomial inequality.